Hello, science enthusiasts and cosmic curiosity seekers. Today, we're diving deep into a groundbreaking revelation with none other than Bill Nye. Recently, an image captured by the Webb telescope has sent shockwaves through the scientific community, and Bill Nye is here to break the silence on its implications. This isn't just any space photo. It's an image that could change everything we know about the universe. Buckle up as we explore the depths of space through this mesmerizing discovery. For decades, Bill Nye the Science Guy has been sparking our curiosity about the cosmos and its enigmas, taking us on a journey to the depths of outer space that stretches boundlessly above us. Now, Bill Nye sheds light on the latest revelations from the James Webb Space Telescope. These breathtaking images take us back over 13 billion years, offering a view that could dramatically reshape our understanding of the universe and potentially our outlook on life itself. The James Webb Space Telescope is revolutionizing our knowledge with its groundbreaking discoveries of distant planets, galaxies, and beyond. Celebrated as a monumental leap forward from its predecessor, the Hubble Space Telescope, the Webb, is not just a scientific breakthrough, it's a game changer. But what about the Webb telescope images that are challenging our existing theories? And what insights does Bill Nye have on these developments? Let's dive in and discover more. The Webb was the culmination of years of painstaking work by NASA scientists and engineers. Launched on Christmas Day in 2021, this mission marks a pivotal moment in space exploration. Join us as we explore these marvels with Bill Nye, understanding how they continue to expand the frontiers of our knowledge. The deployment of the telescope unfolded seamlessly in the months following its launch, and by late June 2022, as the telescope came online, the scientific community was astounded. Almost immediately, researchers began to identify thousands of new galaxies, each one older and farther than any we had known before, some even predating discoveries made by the Hubble telescope by over 150 million years. The capabilities of this new telescope extend far beyond our previous limits. It can collect light from celestial bodies, such as exoplanets and forming stars, revealing not just their existence, but their composition and movements through space. Bill Nye shares that this wealth of data is beginning to unveil the atmospheric details of planets hundreds of light years away, hinting at their potential to harbor life as we know it. One iconic image that has captivated many is the Pillars of Creation in the Eagle Nebula, famously captured by the Hubble telescope. While Hubble's images showed the stunning clouds around the formation, it couldn't see what was happening inside. Now, with Webb's advanced infrared imaging, we are able to peer inside these cosmic nurseries, revealing the ongoing creation hidden from Hubble's view. This new perspective is not just enhancing our understanding of the universe, it's rewriting the textbooks on what lies beyond. In the captivating imagery provided by the James Webb Space Telescope, clusters of dust and gas, each dwarfing our solar system, transform into tiny red specks against the nebulous backdrop of the Pillars of Creation. These are not just specks, but protostar stars in their nascent stages. Bill Nye explains that these young stars, visible in the image, have not yet begun to consume hydrogen. However, as they continue to attract more material, their cores compress further, eventually reaching a critical density. Suddenly, hydrogen burning ignites, catapulting the star's temperature to a fiery 2 million degrees Celsius. The image utilizes varied colors to represent the typically invisible infrared wavelengths, painting an otherworldly picture. To the human eye, these would be red hues, but the image shows them as blue. The colors intensify with the radiation emitted, with the protostars themselves radiating at wavelengths about 6 times beyond the scope of human vision. Bill Nye points out that this image doesn't just showcase Webb's remarkable infrared capabilities, it also illuminates the processes that could have led to the formation of stars like our Sun. Since the discovery of the first exoplanets in the 1990s, over 3,000 confirmed planets have been found orbiting distant stars, hinting at the myriad possibilities of other worlds. This image opens a window, not just to the star's birth, but to the potential of discovering more about the universes far beyond our own. While stars often steal the celestial spotlight, it's the exoplanets that hold some of the cosmos' most intriguing mysteries. Of the thousands discovered, only a handful have been directly imaged, largely because these distant planets are usually only visible when they transit their host stars, causing a slight dimming of light. But the James Webb Space Telescope is changing the game. In September last year, Webb took its first direct photograph of an exoplanet, previously detected in 2017 and named CHIP 65426b. Scientists harnessed the power of the telescope's coronagraphs to block out the light from the central star, utilizing Webb's advanced cameras, a variety of filters, and other sophisticated instruments to capture the image. This planet, a colossal gas giant, is about 12 times the size of Jupiter and sits a staggering 100 times the distance from its star compared to Earth's distance from the Sun, which makes it unusually visible due to its extreme separation and the telescope's unparalleled sensitivity. Adding to the marvels Webb can uncover, even the elusive phantom galaxy, often hidden in the night sky, reveals its brilliance through Webb's infrared camera. The galaxy displays a stunning spiral structure and a rich dispersion of stars, showcasing just how much there is to explore and understand in the vast theater of space. From the radiant center of M74, also known as the Phantom Galaxy, Hubble's optical view reveals arms stretching outward, each a testament to the galaxy's dynamic nature. However, a recent image captured by the James Webb Space Telescope adds a new layer to our understanding. This image showcases intricate structures that resemble fibers of heat emitting dust and gas, all radiating from a brightly glowing center depicted in striking electric blue. This groundbreaking image illuminates the star-forming regions nestled along the galaxy's spiral arms in vivid infrared light. The Hubble Space Telescope and Webb's photographs have been merged to create a breathtaking composite image that showcases both the galaxy's optical and infrared characteristics. This composite was crafted by researchers at the European Space Agency, ESA, as part of the FANGS project, an international initiative utilizing Webb, Hubble, and various ground-based telescopes to capture infrared images of 19 nearby star-forming galaxies. With the crystal-clear observations provided by Webb at longer wavelengths, astronomers are now able to precisely identify star-forming regions in galaxies, accurately gauge the masses and ages of star clusters, and delve deeper into the properties of the tiny dust particles that wander through interstellar space. This synergy of data highlights Webb's distinct diffraction pattern and underscores its role in pushing the boundaries of our cosmic knowledge. In a captivating display of cosmic phenomena, a July image of a distant star, known as a Wolf-Rayet star, revealed an intriguing visual artifact. Surrounding 140, the star at the center was a pattern not just striking, but seemingly surreal, a ripple like a ray of concentric rings with a slightly boxy contour. Unlike the typical diffraction patterns seen in space photography, these unusually shaped rings are genuine features, born from the cosmic dance of massive stars approaching the twilight of their existence. Wolf-Rayet stars, like 140, are in the final stages of their lives and have expelled significant amounts of hydrogen into space. The unique ring-like patterns arise from the interactions between W140 and its smaller companion star, creating a celestial spectacle of fluid shapes and intricate designs. Further showcasing its unmatched capabilities, the James Webb Space Telescope, designed to peer into the furthest reaches of the universe, made a groundbreaking announcement in mid-December last year. Researchers revealed that they had successfully captured images of the 4 oldest known galaxies. Webb first detected these galaxies as they existed 13.4 billion years ago, a mere 350 million years after the Big Bang, representing about 2% of the universe's current age. Thought to be ancient, these galaxies resemble the hundreds of others Webb has discovered, with researchers meticulously determining their ages, unraveling the mysteries of our universe's earliest days. As part of the James Webb Space Telescope's Advanced Deep Extragalactic Survey, JADES astronomers have been using the telescope's near-infrared spectrograph to measure how quickly galaxies are receding from us. This measurement, known as redshift, reveals the stretching of light waves caused by the expanding universe. The highest redshift ever recorded stands at 13.2, indicating galaxies that are far more distant than we ever anticipated before Webb's arrival. For the first time, Webb allows us to pinpoint these incredibly remote galaxies and verify their vast distances through detailed spectroscopy. In addition to its galactic discoveries, Webb has also turned its attention to exoplanets. The telescope has conducted the most comprehensive study yet of a planet named WASP-39b, which orbits a star in the constellation Virgo. Located about 700 light-years away, roughly 8 times closer than Mercury is to the Sun. WASP-39b is a gas giant comparable in size to Saturn. As it orbits its star, this planet's atmosphere, thick with clouds of sulfur and silicates, including sulfur dioxide, heats up dramatically. Using Webb's main camera and 2 of its spectrographs, scientists have successfully detected carbon dioxide in the planet's atmosphere, providing new insights into its composition and conditions. For the first time ever, carbon dioxide has been detected in the atmosphere of an exoplanet. This breakthrough not only sheds light on the planet's atmospheric composition, but also offers clues about its origins and evolution. Researchers believe the planet originally formed much farther from its star, and its current position results from a collision with smaller planetesimals. This is supported by the planet's atmosphere, which contains more oxygen than carbon. Turning our gaze closer to home, Saturn's moon Titan continues to captivate scientists with its unique features. Titan's surface is dotted with rivers, lakes, and seas of liquid methane and ethane, while its rocky surface is composed of water ice. The moon is also shrouded in methane clouds, making it the only moon in our solar system with a dense atmosphere. Webb first glimpsed these clouds in November of last year, collecting invaluable atmospheric data from this intriguing moon. The excitement among researchers was palpable when they realized Webb had captured 2 distinct methane clouds, including one hovering over Kraken Mare, Titan's largest sea. The team's enthusiasm led them to share their findings with Hawaii's Keck Observatory, eager to further explore the mysteries revealed by Webb's observations. Just 2 days after Webb's first glimpse of Titan, Keck Observatory followed up with its own observations. While the cloud over Kraken Mare was visible in the Keck data, its shape had changed, suggesting either that the cloud had shifted or a new one had moved into the same spot. Researchers are excited to use this dynamic information to map Titan's hazy atmosphere and identify new gases present on the moon. Turning to the Southern Ring Nebula, which has long been considered unremarkable by scientists, new revelations are emerging. Traditionally, the nebula was thought to be the result of a white dwarf, a dying star that had shed its outer layers, glowing brightly as it emitted energy waves. The nebula's companion star, part of a binary system, was known to be obscured by the bright atmosphere of the white dwarf. However, Webb's stunning new images, released alongside its initial data, have revealed a more complex picture. Using Webb's near-infrared camera, NIRCom, and mid-infrared instrument, MIRI scientists discovered that the white dwarf was not invisible in the expected wavelengths. Instead, it was emitting a striking red glow and surrounded by a veil of chilly gas. The gas source hidden within the nebula was the only plausible explanation, as it was concealed by the nebula itself. Webb's primary camera also captured intriguing shells around the nebula's edge, resembling the structures seen near Roan 140. Researchers speculate that a third star positioned between the 2 known stars might be responsible for these ripple-like shells. Bill Nye and other experts note that while it seemed like the known stars were responsible for all the gas and dust in the Southern Ring Nebula, these materials were actually being ejected in very specific directions. Interestingly, although Webb wasn't specifically designed to discover exoplanets, it stumbled upon one anyway, though it's not an exoplanet in the traditional sense. The object, named VHS 1256b, is a brown dwarf. It's larger than a planet, but not massive enough to be classified as a star. Brown dwarfs like this one engage in a different kind of fusion than stars, producing a faint reddish glow. Even more astonishing, Webb found that this brown dwarf has sand in its atmosphere, making it a truly unusual find in the cosmos. The discovery of silica clouds around the brown dwarf VHS 1256b is quite remarkable, as this is unusual for an object of this type. Not only is this brown dwarf relatively young and small compared to others, but it also features a unique atmospheric composition. Much like with WASP-39b, Webb was able to identify specific elements in the brown dwarf's peculiar atmosphere, including water, methane, carbon dioxide, and potassium. The ratios of these components suggest a highly dynamic and turbulent atmosphere. In a calmer environment, one would expect a predictable ratio of methane to carbon monoxide. However, the data shows a significant imbalance, indicating turbulent vertical mixing. This mixing brings carbon dioxide from deep within the atmosphere to interact with methane higher up. Bill Nye points out that the ultimate goal for astronomers is to discover new planets and delve deeply into their atmospheres. As part of its initial data release, NASA made Webb's first spectrum of an exoplanet's atmosphere available. This spectrum, essentially a barcode of light wavelengths absorbed by the planet's atmosphere, was created using Webb's spectrographs. The study of these wavelengths provides valuable insights into the composition and behavior of the planet's atmosphere. As the planet WASP-96b passed in front of its star, the light filtering through its atmosphere provided a glimpse into its distant world more than 1,000 light-years away. The spectrum captured revealed water vapor clouds and hazy skies, surprising researchers who had previously believed the planet was cloudless. This discovery challenges our understanding, as water is common in our solar system and suggests that similar atmospheric mechanisms might be at play on other planets. Methane, a key focus in the search for extraterrestrial life, is often associated with biological activity. On Earth, methane is primarily produced by bacteria, so finding methane on another planet could hint at the presence of similar life forms. Researchers had initially interpreted a high sodium signal in WASP-96b's atmosphere as evidence of unusually clear skies. However, the newfound presence of water clouds contradicts this view. As a result, scientists are reevaluating both Webb's latest data and earlier observations to reconcile these findings. While WASP-96b, a hot Jupiter gas giant, shows clear evidence of water, it's important to note that this doesn't necessarily indicate the presence of life. The search for life continues, with these discoveries adding new layers to our understanding of distant worlds. This exoplanet, though only half as massive as Jupiter, is only slightly larger than our solar system's largest planet and completes an orbit around its star every 3.4 days. Its surface temperature soars above 1000 C, making it an extreme world. Bill Nye also highlights the tantalizing possibility of discovering life on distant worlds. If we find a planet orbiting a star with an atmosphere rich in methane, it could suggest the presence of life beyond our solar system. Such a discovery would fundamentally alter our understanding of life itself. We've all wondered if there's another form of life out there, possibly even using their own James Webb Space Telescope to peer back at us, pondering the same questions. Are we truly alone in the universe? As an infrared telescope, Webb has a unique advantage over observatories like Hubble, which primarily uses visible light. Webb's ability to see through cosmic dust allows it to uncover hidden objects that Hubble might miss. For instance, Webb's recent image of merging galaxies previously overlooked by Hubble showed a region of intense star formation. In this area, Stars are being born at a rate 20 times faster than in our own galaxy, revealing an incredibly dynamic and active region of space. In the new image of the merging galaxies labeled IC 1623, the intense star formation releases so much infrared light that it creates Webb's signature pointed star diffraction pattern, a hallmark of its observations of brilliant stars. The dense dust in this region obscures it from Hubble's view, making it appear as a separate layer in the final image. The merger, taking place roughly 270 million light-years from Earth, might also be giving rise to a supermassive black hole, though it's not visible in Webb's image. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.